Now you can either accept that.
Alright folks, the scene we're going to be looking into today is the scene from The Martian. A little background information, our astronaut Mark right here is trapped inside this pod and he's trying to get out so he can go back home with his teammates. Now in order to create a sense of acceleration in space, he pops his spacesuit and kind of pulls an Iron Man here, as you can see, and he's like blasting through space.
Poking a hole in your spacesuit seems like a terrible idea. We want to investigate if it would actually work in space.
In order to further analyze the scene, we went ahead and isolated our video clip and uploaded it to a software called Tracker, which will allow us to track multiple points of Mark's travel throughout the scene. We also made sure to change Mark's mass to 95 kilograms, which is what we assume he would be in space with his spacesuit and all. We were able to collect 6 points, as seen on the right, with their timestamp and distance from the origin. Our 6 data points are seen here in a graph form. The y-axis is the distance from the origin, and the x-axis is a timestamp. So the equation we're going to be using the most today is v equals distance over the change in time. Before we get into all the calculations, we want to say what our assumptions are coming into this. The first is that the units we will be using are meters per second. Second off, that our reference frame for this is the y and x axes we set up in our clip, which is right in the middle of the screen. And then third off is that we are under the assumption that most of the velocity for Mark in space is coming from the fact that he pricked his spacesuit, and that's what's propelling him through the whole thing. Here we are doing the equation for the velocity from the point 1 to point 2. And as you can see, I have the distance values within absolute value brackets because in the scene and the way we set up our y-axis and x-axis, Mark is traveling towards the origin, which means he's going from right to left. So then the values will be negative, and we don't want them. We don't really care if they're negative. We just want to know the difference between the distances. And as you can see here, we plugged in the numbers we found in our Tracker app, and it comes out to be approximately 10.64 meters per second. We went ahead and repeated this process for point 3 to point 4 and point 5 to point 6. And then having all three of the velocities, we took the average and found it to be 9.86 meters per second.
After all our calculations and assumptions, I would have to say that this myth is not busted.
I too agree that this myth is not busted.